Hi everyone, we're going to evaluate the given integral. We're going to use trigonomic substitutions, namely the inverse substitution. And what I mean by inverse substitution is this has this form right here, a squared minus x squared. So what we're going to do is use substitution, and also we're going to use this identity. So basically what I'm going to do is let x equal a. In our case, a, since we have 9, is going to be 3. So square root of 9. So that's going to be sine of theta. And therefore our derivative of x is going to be 3 cosine of theta d theta. Now substituting, we get, let's see, substitute in for x, you're going to get 9 minus 3 sine theta squared divided by 3 sine theta squared. Now this is going to equal, let me move it over here, and we still have our d theta, so let's write that out. So our d theta, or dx, is times 3 cosine theta d theta. So what I was looking at is this upper portion. So this upper portion is going to end up being 9 minus 9 squared of theta, which equals the square root of 9 times 1 minus sine squared of theta. So that's going to equal square root of 9 is 3, and then we have square root of cosine squared of theta, which is 3 absolute value of cosine of theta. Now since we're in quadrants 1 and 4, cosine's positive, so we can just take away the absolute value sign. So it's just going to be 3 cosine of theta. Now, looking at this again, I'm going to write this as 3 cosine theta d theta, 3 cosine of theta for this piece, times this piece, so that's going to be 3 cosine theta d theta. And the denominator is just going to be 9 sine squared of theta. Excuse me. So 3 times 3 is 9. So that's going to cancel these two. And so what we're going to end up having is the integral of cosine times cosine is cosine squared of theta divided by sine squared of theta d theta. Now this equals cotangent. So let's look at that. So when you do cosine squared over sine squared, that's going to end up being cotan squared theta d theta. Now we're going to use our identities and write this so we can take the antiderivative as cosecant squared of theta minus 1 d theta. Now when you integrate this, the antiderivative of cosecant is negative cotan, and then minus the 1, so that's going to be minus theta plus c. Since this is an indefinite integral, we must return to the original variable x. So what we're going to do is use a diagram, a right triangle, and write this out. So let's recall what we did. We let x equal 3 sine of theta. So sine of theta equals x divided by 3. So I'm going to put my theta here. This is a right angle. So sine is opposite over hypothesis, or hypotenuse. So this is going to be x divided by 3. So this is opposite, and this is your radius or your hypotenuse. So to get this, you're going to have y squared equals x squared minus 3 squared. So y is going to be square root of, it's actually going to be, 3 squared minus x squared. So that's going to be 9 minus x. So x squared, So now this side here is just going to be square root of 9 minus x squared. Now let's look at our original integral. Our original integral will be this, what we substituted for. And the side, when you use these right triangles, it's always going to equal this, what we substituted for inverse. All right, so now let's substitute. So we need negative cotan of theta. So cotan, remember, is adjacent over opposite. So adjacent is going to be, so we have our negative here, is going to be square root of 9 minus x squared. And then our opposite is x minus our theta. So on our theta, all we have to do is look at this. So we have x divided by 3 equals sine of theta. So theta equals inverse sine of x divided by 3. So I'm just going to substitute in this theta with sine inverse, or inverse sine, of x divided by 3. And then you have, get rid of that. You still have your plus c. Now we have everything back in terms of x. And that's your final answer. Thank you. Have a nice day. Bye-bye.